Hello, can you hear me?
Yep.
Good afternoon. We are already 42 participants in today's webinar and we can start. Welcome everyone. I am very glad to have you here today. Hope that everybody is in good health. Thank you for joining our webinar from Future Environmentalists project done with the support of Erasmus Program of European Union. My name is Zurnita Strateva and I work for Association of Parks in Bulgaria. This is one of the most powerful non-governmental environmental organizations in Bulgaria, and I'm a coordinator of the Future Environmentalists project. Under the project, we are organizing a series of webinars on subjects and topics related to the nature conservation, and we are hosting this webinar. We are really happy to invite you to join in next webinars to come. Today we will speak about the numerous disturbances in European forests, such as withdrawals, damages from ice and wet snow, fires, insect outbreaks, and etc. I am pleased to present you our lecturer, Professor Momchil Panayotov from Forestry University of Sofia. I'm going to give you the floor to Professor Panayotov, and he will tell more about himself. And please, because Zoom is participatory software, I remind you to keep your microphones muted unless you want to raise questions. You can also use the Zoom chat for any comment or questions. It is situated below the screen. And the webinar will be recorded, and after that will be uploaded in YouTube in a special playlist. And at our educational toolkit website, it is available at edu.parks.bd. Professor Panayotov, the floor is yours.
So hello everybody, I hope you hear me well. Is it okay? Okay, so my name is Momchil Panayotov. I'm a professor at the University of Forestry in Bulgaria, and I'm teaching dendrology, but I'm doing also a lot of research on coniferous forests, subalpine forest disturbances which happen in these forests. These are generally the topics that are interesting for me. And now I guess it's good time to start the presentation. So I'm sharing my screen. The topic of my presentation is natural dynamics and disturbances regime in Bulgarian coniferous forests and how do we study them. So, disturbances and forest disturbances, what are they? What you can see on the image screen is several types of disturbances which affect European forests quite much. We can see fires, we can see ice damages from a heavy ice storm, we can see wind throw on the bottom left, then we can see big bark beetle outbreak which kills a lot of trees simultaneously, and big avalanches. Disturbances are all those events who disrupt the forest. They are often sometimes affecting the forest in large scale. And usually we say that they change something in the landscape. They usually change the structure of the forest, the development phase of the forest, something in the forest. Until many years ago, disturbances were called natural disasters, but the more we learn about them, the more we start to understand that they are part of the natural process in the forest. What you can see on this image, which is from a very well-known paper by Shellhouse in 2008, are some disturbances in Europe in the last decades. You can see that in the last years, after 1970, we have peaks, especially of wind throws and wind throw damages, but also of bark beetles, fires, and all kinds of other disturbances. Now we have a much better picture in the last decades, which shows even bigger disturbances, like the big windstorm in Italy in the last year. Until some years ago, disturbances were accepted only as disasters by foresters, but now the more we learn about disturbances, the more we know that we cannot really exclude them from the forest ecosystem. They are often part of the forest dynamics, the things that happen in a forest naturally. And if you look at these papers, at these titles, we start to understand that we have to learn to live with the disturbances. We cannot live without them. because actually we cannot affect many of them. We cannot stop the hurricane strong winds. We cannot stop many of the insects. We cannot stop many of the big fires, and we have to live with them. Today I'm going to talk much about a study that we made a couple of years ago about a special issue in forest ecology and management. And if you're interested, this is the title page of this special issue, a paper called A Walk on the Wild Side, Disturbance Dynamics and Conservation and Management of European Mountain Forest Ecosystem. And if you read this paper, what you will see is that actually we have data about disturbances in Europe. And I have highlighted the Bulgarian case and the Balkan Peninsula, and you can see some very big disturbances which happened in the past: wind disturbances, fire disturbances, also insects, avalanches. And if you can see this graph well, it shows that in many of the regions in the Alps, in the Apennines, in Bohemian forests in Central Europe, Carpathians, Dinaric Mountains, Northern Europe, we have various types of disturbances, sometimes very, very big ones. So we cannot exclude them from our forests. So let's shift to the Bulgarian cases. According to the European definition of mountain terrain, more than 50%, more than half of the country in Bulgaria are mountains. The highest mountains and the widest mountain ranges are dominated by coniferous forests, and natural coniferous forests have a range between 1,000 and 2,200 meters above sea level. We have quite high diversity in terms of species and genes. I will show later some graphs. And disturbances are still perceived by many foresters in Bulgaria as disasters, which happen regardless of the forest attributes, history, human management. But actually we know it's not like this. A short glimpse of southwestern Bulgaria, which is mostly high mountains. What you can see is all these colors are showing forests, different kind of forests, dependent on the dominant species. The orange is Pinus sylvestris, the green is Picea abies, the light blue is Abies alba, then the red is Pinus nigra forest, and this violet here, it's very specific kind of Balkan-specific forest, Pinus hildreichi and Pinus peuce, two species that grow to very high ages, more than 1,000 years ago. These graphs show the distribution of these forests in the vertical diapason, and you can see from about 500 meters, which is Pinus nigra, the lowest situation coniferous forest, to 2,200 meters, which is the local tree line in Bulgaria. And this bottom right graph shows the area which is occupied by different species and their age. And you can see that the highest area is occupied by Pinus sylvestris forest, but these are mostly young forests, below 120 years, and there is a reason about that. Spruce forests are the second place, and we have higher share of older forests between spruce forests. The oldest forests are Pinus hildreichi, Pinus peuce, and isolated Pinus nigra forests, but they occupy quite low territories in Bulgaria. More about this kind of forest you can see in this book, which is written in Bulgarian, but also has English abstracts for each chapter. And the book, Mountain Coniferous Forests in Bulgaria, Structure and Natural Dynamics, is available in PDF, in ResearchGate, or if somebody cannot access it, you can write us a message and I will send you a link. So some historical background about Bulgaria, some specific things which reflect later the forests. Bulgaria is a bit different from the European Alps in terms of least some important aspects. There were almost no constant settlements in our mountains. People did not live all the time in the mountain landscape, so they did not affect it all the time. People lived mostly in the summer months, going up there for their activities. Most of the activities were related to sheep breeding, which was the big business. So the people needed really the flat ridges of the mountains, which are good for sheep breeding. They didn't care about these steep slopes which are occupied by forests. Timber extraction was very limited. until the 19th century and was only close to the villages and in the lower part of the mountains. Some exceptions are for Vitusha Mountain and for the northern slopes of Rila Mountain, close to Samokov city, where people needed to cut more trees for the local metal ore industry, which needs a lot of wood. During the Ottoman Empire, actually, there were some groups with more privileges, they're called Yuruzi. They had more privileges on the use of grass and water for the sheep breeding. So they could use all the pastures for the sheep, but they had no interest in the trees. What they used to do was set deliberate fires in autumn. Why? Because in this way they burned some trees and cleared the grass for the next summer. After they set the fires, they left for the agency region with their herds, where they could still access grass even in the winter. This led to many fires in the Rhodopos and the Rila Mountains, especially in the 18th and 19th centuries. In the many locations, the local tree line was depressed. Probably the high altitude spruce forests were heavily affected by these fires. If the fires run to lower altitudes or to wider territories, these left long-lasting legacies in the forest. A serious problem for researchers like me is the almost complete lack of data about forests. The Ottomans did not have a strict forestry system until almost the collapse of the empire, which was the end of the 19th century. Therefore, we cannot rely on all documentation and maps. There are only limited notes about these events, which cannot help very much when studying the past history. These first written notes date from the end of the 19th century and are about the liberated territories of Bulgaria. Parts of southwestern Bulgaria, for which I speak today, remain in the Ottoman Empire until 1911. So you can see that we cannot count very much on historical documentation. In this paper, which I will mention a lot of times today, we have tried to make a review collecting all the available data about forest disturbances in coniferous forest. What are the data sources that we looked for and we used? The oldest and most comprehensive is the oldest forestry map in Bulgaria, which was made in 1895 by a very well-trained forester, Konstantin Baykushev. He also had a description book next to the map, which is really very precious document because he described various forest patches, how they looked, what were the dominant species, if they were affected by humans, why and when. So this is really very precious document about us. You can see here a print of the map, and you can see these arrows which actually point to big fires in certain districts. What we made is actually that we digitalized this map, we connected it to modern day features, and here you can see digitalized version of the map, the same map. These arrows here, they point the fires that were seen on the previous screen. Then here with the violet, you have coniferous forest. The more intense the color, the older the forest. So you can see from this map that we can see what was the situation 100 years ago, what were the dominant species, what were the age of the forest, if there were some big fires, etc. So this is a very good source of data for the territory which is covered by this map. What do we do when we don't have this map? We also rely a lot on written notes in the specialized forestry literature. Mostly these are forestry books, old textbooks, articles written by foresters, which date the beginning of the 20th century and which cover the past periods. We also have a wealth of recent observations from foresters, people who worked in the last 50 years in these forests. They know very well the region, so they gave us some information about disturbances that they knew in certain regions. And then when we have these data, we verify these notes with satellite images and with orthophoto images sometimes. by which we can have better estimate of the spatial extent of some disturbances. And we used our tree-ring based studies, which we have worked for in the last 15 years. We have studied in detail 3 Norway spruce-dominated reserves. I will present them later on. 1 Pinus-Hildreichi forest also, and I will tell more about them in some minutes. All of these, of course, is input into a database. So here, just a map which also shows the region which we worked in. And with these stars, you can see the positions of the forest that we studied in detail by tree-ring analysis and more additional data. I will tell now shortly about these forests. The first is Parangalica, which is one of the really beautiful Bulgarian reserves. It's an old growth unmanaged Norway spruce-dominated forest. It's a very diverse, very interesting forest. It's one of the few forests like this which have remained in Europe, Norway spruce-dominated unmanaged forest. You can see some pictures from it. This specific location, you can see a lot of dead big trees. Then another location, these are mostly spruce and fir trees. Some of the dead ones have died, and now you can see one of my colleagues, Nikolai Tsvetanov, who is measuring young ones. Then this is an old disturbance from the 1960s. This was a big wind throw, which you can see is very well regenerated right now. Another spruce forest that we studied is Beglica. It's also a very specific reserve in the central part of the Rhodope Mountains. It's a subalpine Norway spruce forest. Again, multi-cohort forest with various ages, but much less diverse in structures than Parangalica Reserve. Another spruce forest that we studied is Bistriško-Branište Forest Reserve. It's again pure Norway spruce forest, but it has much more simple structure and almost even-aged forest. It has a legacy of heavy human management until about 1850, and this heavy human management actually resulted in the forest structure nowadays and in everything that happened in the last 20 years in this forest. You can see from this picture that it was heavily affected by bark beetle outbreak, and many of the old trees are actually dead by now. Another forest that we present here that we studied in detail by the means of tree-ring analysis is in the Bulgarian Mountains National Park in Bulgaria. Subalpine and tree-line old growth forest composed of Pinus hildreichi and Pinus peuce. Those two species that can really grow to very old trees. We have numerous trees above 500 years, but there are also trees which are probably more than 1,000 years. So you can see very, very old ancient forests. Very few of these forests have remained in Europe. So a little reminder on on how we use tree rings to tell us about the old past of the forest. Usually we look in the changes of tree ring width, and you can see on this picture that sometimes trees respond very sharply to some events. With the bottom arrow, you can see scanned image from a big tree, which was released by a wind throw which happened in the vicinity in 1983 in that case. And you can see on the bottom, on the top graph, the very, very sharp increase of the tree ring width. We call this a release, and this is usually a sign that the neighboring trees died. So this tree could use much better the resources for itself and increase very sharply its growth. What we know from our studies is that actually sometimes we don't have only releases, but we also have suppressions. In this specific case, you see a suppression after 1962. Until 1962, the tree was growing very well, and then all of a sudden it started growing very slowly. Why? Because its crown was damaged by strong wind. This strong wind affected a lot of the territory of this same forest. It was a big wind throw. When we combine this data from the tree rings together with spatial position of the responding trees and the forest structure and photos, orthophotos in this case, we can reconstruct sometimes what happened when it happened, like a wind throw, a bark beetle, something like this. In this specific case, you can see with the light blue patch that is much younger from the forest which is to its right. And this much younger patch is due to wind throw which happened more than 100 years ago and then resulted in regeneration of a young forest. So let's take a look into these detailed forests studies. The first thing is the Parangalica Reserve. You can see here the various structures that dominate the patches. And we can see that there are different structures in this forest. It's not only one simple forest with simple structure. We have patches which have different structure. Of course, this is related also to the age of these patches. And we can see also a mosaic of different ages. We have some very young forests, which are 40 to 80 years old forests. These are forests that were affected by wind throws about 60 years ago. Then we have some younger forests, about 100 years. Then we have older, about 160 to 200. And then we have forest patches that are more than 200 years old. All this mosaic is actually reflecting all disturbances. On this map, you can see disturbances, mostly wind throw, that we have dated. So we know when they happened and when they happened. So with the light green, you can see disturbances after 1962. Then with this blue color, the light blue, between 1965 and 1997. With yellow between 1998 and 2008. And the oldest one are with pink, which happened more than 60 years ago, but mostly more than 100 years ago. And we know all this history about this forest, and looking into this map, you can see that actually most of the forest was affected by disturbances, mostly wind throws, in the last 200 years. So this natural forest that was not managed by humans was actually managed by the wind throws. And an interesting question is how old were the forests when they were affected by these wind throws? We know that by the date of the ages of the trees that compose this forest, always there are some survival trees which can tell us when the disturbance happened and how old was the forest before that. So you can see that most of the disturbances happened in forests that were between 120 and 200 years old, especially 120 and to 160 years old. This was the most affected Norway spruce forest, especially by large-scale disturbances. The old growth forest, which is marked with dark brown, is affected by mostly small-scale disturbances, which is rather different in terms of the later effects on the forest. This is a generalized picture from the tree rings, and what you can see on it are three different things, actually two different things. The shaded gray and black show the releases, accumulated number of releases in trees, and the green shows number of trees which occurred in this moment. So they started to grow at this decade. So you can see that we have arrows here which indicate high number of trees which react by releases in these decades, or high number of trees that started to grow actually in these decades. This all shows episodes of disturbances. And we know from this graph that we have different episodes occurring in this forest. It's not one disturbance, there are not two disturbances, it's many repeating disturbances in the years. And if we look only in one of the most old growth patches, we even see more and more of this. We can see one episode with high number of reacting trees. This was in 1890, very high number of reacting trees. But if we look in the other decades, we also see that all the time there are some trees that will respond with very high release in their growth, which means that all the time there are trees that die there and other trees benefit from this death. This is a continuous process that is kind of non-stop process. Now let's look in the Bistriș-Cubraniște Reserve. This was the younger forest that was heavily affected by disturbances. If you look at the bottom left graph, all this shows some recent disturbances. This color here, the pinkish color, shows a wind throw in 1956. The dark brown color shows a wind throw in 2009. Then we have a fire which occurred in 2012. And we have the big bark beetle outbreak, which happened after the wind throw in 2001 and continued until about 2012. This is in the middle graph. You can see with the colors how it started around the wind throw and then expanded very much. And in the right graph, you can see the age of this forest before it was disturbed by these disturbances. And if you compare these three graphs, you can see that the most heavily affected was the oldest forest, the thing that is with the dark brownish color on the bottom right, and the forest that was youngest with this yellowish color, it was almost not affected by the bark beetle. And this is really interesting to note because it has later on effects. One fast conclusion is that when you have large forests with one age with simple structure, like the forest that was in the center of this reserve, it is very, very easily affected by large-scale disturbances. It is very susceptible to them. The tree ring data about this same forest, you can see that many of the trees occurred, they started to grow after 1870. And this reflects the stop of heavy human management, which was about 1850. In 1850, people stopped cutting this forest because until then, they needed a lot of wood in this region. But then the Ottoman Empire started to collapse. This metal reproduction industry really collapsed and people stopped cutting this forest. Then you have a second wave of regenerating trees in the 1930s, and this is when the reserve was declared. People stopped using this forest for sheep breeding, and the trees really started to grow more and more. More and more trees occurred there. But then you still have some trees which shows that there were some gaps forming in this forest. However, this forest was kind of too young, and when the big disturbance occurred in 2001, it could not cope with it. What about the third forest, this subalpine spruce forest, the Beglica Reserve? It's actually much more different than the other ones. What we have seen there is that there are numerous small-scale gap disturbances. There are single wind throws, but they are not so big. We have suspicion for one very big fire in the vicinity, but we could not find enough data to really tell when this fire happened, how it started, and so on. And in the close proximity of this reserve, there is one huge wind throw which happened in 1961, 3,000 hectare wind throw, which did not affect this reserve heavily. And if we look in the tree ring graph from this reserve, we can see that all the time there are trees that respond very sharply with these black bars, and this shows that we have all the time process of mortality and process of trees that start to grow. This is a continuous gap dynamics process, continuous mortality, which is very typical for this subalpine spruce forest. So by comparing these three spruce forests, we can see that in one type of forest, this is spruce, we can have very different picture, and this depends very much on the initial situation in this forest. What is the initial structure? What was the past of this forest? Everything is related. So what if we look in the historical database from all the data that we have collected? All this data actually shows that we have most numerous in Bulgarian coniferous forests wind throws and fires. Fires are actually most numerous. We have also data about snow-related damages, mostly related to snow breakages of trees, but also of ice damages and avalanches. But these are either not complete data. For example, we know that we have many avalanches, but we have just single records about avalanches. This means that people didn't record well enough these events, or sometimes the forests were not interested in these events. I start with windthrows. This is an old picture from 1932 in the region Cemberlia, which is in Rila Mountains. It's the personal archive of Dimitar Zagorov, one of the very famous Bulgarian foresters in this period. And you can see really almost total devastation of this forest. And this is a general overview of such disturbances which happened. These blue circles actually indicate how big was the windthrow. And the biggest circles are the biggest windthrows. And you can see that we have at least 5 windthrows that were more than 500 hectares big. The biggest one was 3,000 hectares. This is this one in the center of the Rhodope Mountains. And you can see actually that windthrows are not something new for Bulgaria. They are not something limited to only one location. They happened in our spruce forest. If we see the type of forest which was affected by windthrows, without surprise, the most affected was Norway spruce forest. Norway spruce forest, more than 50% of the cases with windthrows were in Norway spruce forest. Why is this typical for Norway spruce? Because Norway spruce usually grows with very shallow root system, which means that when there is very strong wind, these trees fall very easily. What was surprising for us was that actually we have windthrows also in pine forest. Usually pines are quite strong trees. They really are not usually related to windthrows. Why so? Because they have very strong root system. But from our data, we see that we have in Pinus sylvestris, also in Pinus peuce forest, we have windthrows, which was really a surprise for us. If we look into the time diagram, we see a very sharp increase after the 1960s with increase of the number of the windthrows. This is something that is the same in Europe, in other countries in Europe, and it is something related not only to strong winds, it's also related to the forests. Because in Europe, many plantations were done at the beginning of the last century with spruce because it's valuable species. And now these trees have become big enough to be really affected very easily by the strong winds. So this is something that is not exactly the same in Bulgaria because we didn't plant so many spruce trees. But in the 1960s, it seems that a lot of these forests were old enough to be really affected easily by strong winds. The next disturbance, fires. You can see here a very interesting picture from a fire. It's a huge fire which happened in this Bistrish-Kubranište Reserve Forest. And this is a very famous fire because it's just above the capital of Bulgaria. So when this fire was burning, it was burning for several days. All the capital of Bulgaria could see the fire above their heads. People were really asking what's going on, what is this big fire? Will it reach the city? What's going on really? And it was really very famous situation. But when we look into this map, we actually see that we have a lot of fires that occurred in the past. And sometimes these fires were quite large. The biggest circles here represent fires that were more than 5,000 hectares big. They happened in the Rhodope Mountains. They happened at the end of the 19th century. We know about 2 of them that they were started by humans. And actually more than 90% of these fires start by humans. It's not only a Bulgarian case, it's a case for whole Europe. Most of the fires are started by humans, mostly by mistakes, but sometimes deliberately. And if the conditions are right for the fire, it spreads in the forest and it's really sometimes very hard to control it. On this map, you can see only fires more than 1 hectare, forest fires. I have excluded the smallest fires from this map. If we look into what kind of forest was affected by fires, it's a more diverse picture. We have mostly Pinus sylvestris forests affected by fires, but also general conifer type without specific dominant species, also heavily affected. But we also have fires in Piceabias forest, which is generally not related to fires. Not shown on this graph is the fact that we also have recently a lot of fires in beech forest, which usually we don't perceive as susceptible to fires. And we also have fires in Pinus peuce, Pinus mugu, as mixed forests in the subalpine belt. If we look into the time graph, we see that we actually have high increase in the number of fires after the 1990s. And this is two graphs. The top graph is for the whole territory of the country, and the bottom graph is only for the mountain regions above 1,000 meters above sea level. And you can see the same picture. Actually, we have increased the fire after the 1990s. Why is this? Many factors are occurring at the same time. One thing is that we have a lot of fires which occurred by human activities, of course, in the last decades. But then we have also increase of drought events. This is something that we really can see. The drought years are those years with high number of fires. If you look at the top and the bottom graph, you see that we have fires in the 1940s, here also in the 1940s. We have fires in the 1920s. You can see them here also. We have had fires in the past of the 19th century, and we have fires recently. And all of these are drought episodes in Bulgaria. We know them very well. So in order to have big fire, in order to have high number of fires, it's not only enough to have ignition, but you have to have the right burning conditions. If we want to look further back in time for the times when we didn't have written stories, we have to rely only on the tree rings. And what you can see here on this picture is a Pinus heldraichi tree, disc from it, and several fire scars, scar 1, scar 2, scar 3. These scars are left from fires that burned the tree but did not kill the tree, and the tree could overgrow then the scars. And we can either take discs like this one or take tree ring cores by increment borer, because these forests are protected and we cannot go with the chainsaw and cut tree after tree, so we have to take cores. And by using this method with some really hard work that was done by Pepa Vasilyeva, we could actually reconstruct some fires which happened into Pinus heldraichi and Pinus peuce forests in the Pyrenean Mountains. I want to know that this data is point data. We don't know really the exact size of these fires, but we can at least tell some of the locations and the years. And if you look into this graph, these black lines indicate fire scars in different trees. And you can see with the red ellipses, some years in which we have a number of trees which show these fires. And sometimes these trees are in different valleys, like this E, D, C, B, A. On the right, these are different locations from where we could collect these trees. Sometimes all the fires are in one location, like this 8028, found only in one location. And sometimes they repeat in different locations. And if we want to look onto the map, the same data, you can see, for example, this 7024, which occurred in several different valleys in the mountain. Also 1803, again in several different valleys in the mountain. Also 1946, again in several different valleys in these mountains. What this shows is actually we have fire years. And in these fire years, the fire occurred not only in one small location. And this is usually related to climate, to droughts. This means that if somebody lighted one fire, it's not only this problem. Then in this year, we had fires in different locations. And we can also tell that these forests evolved in a fire regime. There were some periodic fires which occurred every 100 or 200 years apart, and this is not something new. And these trees are really used to cope with this fire regime. They have very thick bark, for example. They also benefit for their regeneration after the fires, which means that if we want completely to stop fires in these kind of forests, we are not actually doing what nature really does. Now I switch to another kind of disturbance, the wet snow events. We have not so much data on occasions of wet snow events, but this is an obvious problem for certain forest types. Most of the forests that were affected by heavy snows are young and dense pine plantations, which are located between 800 and 1,300 meters. And usually this belt is related to beech and mixed spruce fir beech forest. So in many of the cases, these plantations were made not in the primary location of the species Pinus sylvestris. Sometimes these snow damages are really big. For example, in 2015, we had a lot of these damages in the Rhodope Mountains, and we had more than 1 million cubic meter of affected trees. We also had similar but not so big snow damages in 1988 and also in the 1930s. So here we see a situation of disturbance which is related also to human activity, the plantations in the past. We have clear link with other events, former large-scale pine plantations, without the necessary thinning treatment by human in the last decades. Bulgaria was not really doing what the old foresters had planned 50 years ago when they planted these forests. In the last decades, many of the thinning procedures were not carried out. We also have legacies of former fires, which happened 100 years ago or even older fires, and then Pinus sylvestris regenerated in these locations and formed young forests. And when these young forests were 30, 40, 50 years old, when a wet snow occurred, they were heavily damaged. However, in the recent years, we also have effects on older spruce forests, which normally should have no problem with wet snow. For example, last year we had really heavy damages from wet snow, which occurred in subalpine forests in the Rhodope Mountains. Probably these events will increase in future with unusual wet snow events at higher altitude, which happens because of warming winters. And the big problem is, like with WINDTHROWS, that after these heavy snow damages, we have bark beetle outbreaks after that. And after this snow damage in 2015, we had a bark beetle outbreak in these pine plantations, and it is almost stopped right now, but we had much larger damages by the bark beetle than by the snow event. What about ice loading damages? I want to stress that these are problems mostly for deciduous forests in Bulgaria. We didn't have much problems like this in coniferous forests. It's mostly problem for beech, but we didn't have such heavy, large storms like these storms in Slovenia, if you have heard about them. They are due to very specific meteorological events. These are the freezing rains, and these freezing rains are not so frequent in Bulgaria. They are actually frequent in eastern Bulgaria, close to the Black Sea, but we don't have so much forest there, so there is not so big effect there. But maybe in future they will become more frequent. We don't know about that. And what about avalanches? They're an obvious problem for steep forests in the high mountains, like in the Pirin Mountains and some valleys in the Rila Mountains. What you can see on this image is Tudorka Peak, one very famous peak because we have a big resort on its slopes, the Bansko Resort. And all these lines that you see in the forest is done by avalanches, big avalanches which fall periodically. And we have written notes about big avalanches in the 1950s, in the 1960s. Some of them led to many dead people, workers in the forest. Then in these years, it was quite normal to work in the forest in the winter, and many people died. In the recent decades, they are not a problem for so many people. There are not any more workers in the winter forests, but now we have more tourists in these forests, so it's more a problem for tourists. And yes, we have a lot of information about avalanches, but they are not so well documented until now. So, some of the problem with the data and the management. about these disturbances. First, we really have a problem analyzing these data because we don't have real good spatial coverage for all the region that we want to study by all the sources of data. So we have certain lack of data, which limits us to really understand the whole picture. The most absurd problem is that we continue to have this problem even nowadays. Today we have really very powerful computers, we have GIS systems. It's really not so hard to make a very comprehensive, good, strong database which collects all the data. But still our forestry system does not support such database. So most of the data is still written on papers, which makes really very hard to make fast, quick analysis of the data. And we are still in Bulgaria living in the total exclusion era. This means that our forests really try to stop all disturbance. They don't want to use them. They don't want to accept them. We still have not reached to the learn to live with era. This is a potential very big problem because sometimes the more you try to escape a disturbance, the bigger the later problems. For example, in the USA with fires, the USA Forestry Service was very successful in fighting fires for almost a century. But now, in the last decades, they have huge fires which they cannot control sometimes. Why this? Because sooner or later the forests start to burn, and when you have a lot of burning material, the fire goes really out of control. So what they have learned is that if a system burns frequently, there are fires in certain type of forests, it's much better to have controlled fires from time to time and to limit the chance for a big uncontrolled fire. And this is something that's well understood in Southern Europe, for example, in Spain, and it's used quite much in the recent decades. But the Bulgarian forestry system still does not even want to discuss any options like this. And I personally expect big problems, for example, in Pinus nigra forests in future. So, hard to explore the possible relationships even with modern data. For example, fire promotes in most cases regeneration of pines, which are on their turn more resilient to wind throws. This means that we have high legacy, and this means that one disturbance can lead to later effects, which makes the forest more resistant to another kind of disturbance, but more prone to another type of disturbance. This is something that's really hard to understand sometimes, but we have to start to understand these processes. Second, we have currently many Pinus sylvestris dominated forests, the canopy, but we have second floor of Picea habeas forests. And sometimes it already reaches the canopy. These are former Picea forests, which were sometimes heavily cut or burned about 100 years ago. What this means is that soon these forests will be pure Picea forest, and it will be much more susceptible to wind throws in future, like say in 20, 30 to 50 years. This forest that is now pine dominated will be spruce dominated, and we will have more chance for wind throws. In terms of climate change and development phases, most forests that we have now, coniferous, are 80 plus years old or more than 100 years old. This, together with the higher chances of more severe weather like storms and more droughts, may facilitate increase in large-scale disturbances. Like if we have stronger winds in future, this together with other forests about 120 years old spruce forest means higher chance for wind throw, and there higher chance for bark beetle outbreak. Up to recently, bark beetles were not a major problem in our natural forest, but with the increase of chance for storm damage and the increases of temperatures, we have increased potential for bark beetles even in high mountains. Why? Because higher temperatures usually mean better chances for the bark beetles. They can have several breeds in 1 year, they affect more trees, they can grow to higher altitudes. And this is bigger chance for a problem. And of course, with forest fires, if we have increased summer droughts and autumn droughts, something that is predicted for the region of Bulgaria and something that is already observed, combined with large territories of continuous coniferous forest and very limited capacity to fight big fires, we have big problem in future. We have to really say that we have big problem with our capacity to fight big fires, and we urgently need real modernization in this aspect. What can we do? We can try to make our forest more resilient. What means more resilient? This is a forest which has really better capability to go back into stable, normal state. How do we do that? With higher diversity. The more species we have in one forest, the more diversity in structures, in ages, it means better chances to recover after large-scale disturbances. I want to show you the picture on the bottom. This picture is the Bistriško-Branište Reserve. The one was affected by large wind throw, then by large bark beetle, then by fire. And what you can see is one location. This is actually the wind throw area. And now it's starting to regenerate very well. But if you look, you can see different colors. The dark green are spruce trees, the light green are beech trees, also some poplar trees, also some birch trees, different species, which means more diverse forests in future. And if we have more diverse forests in future, this means that at least in the next 100, 150 years, this forest will be much more resilient to this kind of disturbance. So this is something that we can do with forestry activities. We can plan and we can try to make our forests more diverse. And we can also learn more from nature, because these forests evolved in thousands and thousands of years, and they sometimes evolve together with these disturbances. And if we look carefully what nature does, then we can try to imitate the process in nature. These are good lessons. So I think I am kind of in time, and I'm open for questions if there are.
Can I ask a question?
Yeah.
If controlled fires are suitable for coniferous plantations, dense coniferous plantations, and also are they suitable for coniferous plantations at low altitudes belt, for which generally is oak altitude belt, and coniferous species are only pioneers in that belt.
Yeah. So the controlled fires are not very good opportunity for very dense forest. First, they have to be thinned, and they have to really grow a little bit older sometimes to have bigger, thicker bark, and then they are more suitable for controlled fires. Because if there is a fire in a young plantation, the whole of it burns completely.
Thank you.
Okay.
Just to ask, are you hearing me right now?
Yeah.
According to current studies, what is the actual percentage of old growth forests in Bulgaria according to just new or disturbed or untouched forests? What is the percentage of untouched forests, actual old growth?
Well, this is very much disputed because there are different definitions of old growth, but it's less than several percent. 3-4% maybe. Depends,
of course, in the
on the
mountains
definition. Can you repeat?
It's of course in the mountains mainly.
It's totally in the mountains. We have very, very small locations of old growth forest, which is not even completely old growth in the valleys. Mm-hmm. The problem is that the valleys were heavily managed, most of these forests, And there are only very, very few tiny small locations which are kind of older, but even they are not old growth forest.
Thank you very much.
Yep.
Can I ask one more question?
Yeah.
Regarding controlled fires?
Yeah.
Is there any relation when they are more more suitable or not so suitable related to season? For example, in summer, the drought could be quite strong, and probably the upper soil layer could be more susceptible to firing, for example, just to disappear. And probably there is some need to plant such fires in more wet part of the year.
Yeah.
I don't know what is the American experience. That's why I'm asking how they're doing that in America.
Well, this is the difference between controlled and uncontrolled fire. The uncontrolled fire burns when it's very dry. The controlled burning is always done when there is high moisture and lower temperature. So this is a very careful choice by the managers of this event. Before the controlled fire, the forest is prepared. There are people there who are ready to really control the fire, and they really choose a moment with high moisture when the fire cannot grow big. Otherwise, it will go out of control. And every now and then, some controlled fires go out of control. This is part of the risk. But if in advance they have taken measures not to really have big burning, usually they can control at least that.
Okay, thank you.
Yeah. So there is a very good experience in this in Western Europe. So Spain, Portugal really had big problem, if you remember, 2 years ago with uncontrolled fire. So they have started to gain also experience. Italy now starts to get experience. Northern Europe, in Scandinavia, they start also to learn how to do that. And the most experienced actually are in South Africa and Australia.
Can I just add some information about some other species, animal species, and that in wet season and cold season, they could be much more protected sometimes, because, for example, tortoises, protected species and very rare species, they're very common victim of fires and of forest fires as well. But if they're deeply in the soil, this is, for example, in Bulgaria, is from November to beginning of March. It will be much more safe for the tortoises. For example, if there will be fires, so there will be not fires, because they're deeply they're deep in the earth. So it's probably also necessary to think about the species living in the forest, which season is the best one.
Yeah.
Just to make this remark, if there will be discussions to have this into account in mind.
Yeah. Okay, so there were questions about bark beetles. It's really very, very specific topic, the bark beetle management. There is no simple answer to bark beetles. In Europe, the biggest bark beetles were with Ips typographus, which is a very specialized bark beetle for spruce forest. And almost in all cases, when people tried to manage this bark beetle by salvage heavy cutting, they could not really limit the bark beetle spread. They could collect the wood, but sometimes this caused much more other damages. Like in Slovakia, in Romania, in Austria, they had a lot of disputes about that. In Bulgaria, we have experience also with other type of bark beetle in the recent several years, which affected pine plantations. We usually try to collect this wood. Usually it is too late to control the bark beetle because the insects have already left away and flown to another trees. So we actually collect the wood. That's what we do. We don't really control the bark beetle. What we have learned in the last 2 decades is actually that the control of the bark beetle is much more natural. People really cannot manage this so much. Nature manages it very much. And about the fire damage after the bark beetles, Yes, if we collect the wood, then there is a lower risk for bigger fires. The question is really not to cause too much other damages when we collect this wood. This is very tricky and really requires a lot of careful thinking how to do it. And what about climate change and bark beetles? There is a lot of modeling work done in Central Europe about that, and it shows really that with warming climate, there is higher risk for bark beetles and for other insect problems also. So this is something that may become much bigger problem in future for our forests. And about other studies in Bulgaria in relation to climate change and disturbances, there are some other studies about forests, I mean. Forest is my topic. So Tsvetan Zlatanov, for example, is one researcher that did a lot of modeling on this topic for the Rhodope Mountains, for example. And there are such studies, but I would say that there is much bigger need for that. Like last year, actually not last year, 2 years ago, I was involved into writing a big project about climate change in Bulgaria. And there was also a topic about forests. And one of the conclusions is that actually we don't have enough scientific data and enough modeling data for Bulgaria for this topic. We need much more.
Excuse me, and someone else is speaking before me.
Yeah, you go ahead first.
I was going to ask to what degree are the bark beetles that are currently affecting Bulgaria invasive and not supposed to be in this region, and to what degree are they actually from here and have always been here, just not in this number?
Good question. The biggest problem is with species that are local. We have one species that is kind of a bigger problem, which is it evolved. It's not completely local, but most of them are local. With invasive species, we don't have such large problems with bark beetles. We have different kind of invasive species problems, mostly with fungi. Like we have one problem with elm trees. It's called the Dutch disease. We also have problem with chestnut trees, the cancer on the bark of chestnuts. Both of them are caused by fungi which were transferred from China, no big surprise, 100 years ago, and they cause really big problems in Europe. So we are really afraid of further problems with invasive species of insects or fungi. This is very, very high risk, and it's very hard to control this process. It requires really very good authorities, very strong authorities, capable of predicting the future, and this is not the case with Bulgaria. Now with the open movement of people, of markets, it's very hard to control these tiny diseases.
And just to ask one more thing, do you actually know the name in Latin of the fungal species, the couple you mentioned, which affect the elm and the spruce, you said, trees? No, just the elm and the chestnut trees.
I will make a mistake if I try to take the exact name now. If you want, I can check on the other computer and write it down in a few minutes, but not to make a mistake.
Okay, thank you very much.
Yeah, there is a question about prevention measures in coniferous forests in national park. Actually, in national park, the idea is not to make a lot of human activities. And the idea is not really to try to make much prevention measures, because often this is an excuse for cuttings, for large-scale cuttings. So it's considered that it's better to leave things to nature and only act in very, very severe cases. It's not good to allow really people to do much things in natural parks.
I have a question about the fires, and looking at the graph where the country had drought years, and seeing that it's coming back again with high intensity, high temperatures, I guess due to climate change and other reasons, is there any measures that the authorities have taken in consideration to that, or it's kind of been left to nature?
Well, most of the measures are usually related to improving the capacity for firefighting. There is work that has been done, but there is a lot more to do, I'm sure about that. For example, we can improve a lot of use of remote sensing, like satellite data on European level. There is very good work in that respect. We can use this more in Bulgaria about the risk for fire in certain periods. Some years ago, we proposed and started a small project on making models where is really the highest susceptible forest for fires, having models which can run real time if there is a fire to really plan how to fight the fire. But there is much more work that can be done in terms of preparing certain forests for lower fire risk. This is a very complex topic. It requires really a lot of brain, I would say, and we are not really doing enough in this respect. I mean, the authorities.
Thanks for that answer. That was very good. Just one other question. I guess more of the information and measures have been taken into fighting it. But what about prevention? Doing something before it gets to the point of having to fight a fire. Just out of curiosity, have there been any projects, any work done about simply teaching people what to do and not to do? Because as you mentioned in the presentation earlier, most of the reasons were human impact. I mean, people's mistakes.
Yeah. Well, the thing is that usually those people who are prepared are the forest workers. They know very well about fires, and there are firefighting plans in every forestry district. And sometimes, for example, if you travel in the Rhodope Mountains, you can see that next to the road there is a strip of land that has been cleared from vegetation. This has been done manually, and the idea is that if somebody throws like a cigarette, it should not light a fire in the forest. So this is something that has been done like a prevention measure. And in terms of ordinary people, there is much more to do. The bigger problem is that actually some ordinary people make fires in grasses in order to clean the grass from, even from the grass, because they want to have a clean territory, and then this fire escapes in the forest. And this is a huge problem right now. Like we have a very high number of fires already this year, and this is all fires that were made by people in grasslands. These people want just to clean the grass from bushes because they get subsidies if they can show that they treat this grassland as a pasture. Of course, there can be political measures about that, but we still have not seen adequate measures which really can make the people think about this problem and stop making these fires.
Thank you very much.
So I see a question about insects. Why are they looked in disturbance studies? Because insects are part of the disturbances, but these are usually biotic disturbances. They are also sometimes natural disturbances, and that's why we also pay attention to them. And if the fire sources are found, if this is a question for where the fire started, usually the firefighters can understand where the fire started. And that's how they can tell that usually most of the fires start from grasslands, because they can really find clues from where the fire started based on the burning. And we don't have many cases for people deliberately starting fire in a forest. At least we don't know about many cases like this. We hope we don't have much like this in future.
Do you have another questions? If no, thank you very much to Professor Panayotov. Thank you very much for your attendance in our webinar organized under the Erasmus Plus program. The next one will be on 23rd of April at 7 p.m.
Okay, thank you very much also. And if somebody has another question, you can also write a message to Zurnitsa and then she will send it to me and I will send back an answer, or write directly to me and I will be glad to give an answer.
And we will upload the recording of this webinar in YouTube. We will be shared in the Facebook event.
Okay.
Okay. Thank you.
Thanks, everybody.
Have a good evening. Nice evening.